Hey everyone, welcome to WirelessPro. Today we're kicking off an exciting video series where we explore how artificial intelligence and machine learning are revolutionizing the world of 5G advanced and paving the way for 6G. Specifically, we'll be diving deep into groundbreaking studies from 3GPP. That's the organization responsible for setting the global standards for mobile communication, looking at how AI and ML are making your mobile experience even better. In this first video, we're focusing on a critical aspect of 5G advanced performance, CSI feedback enhancement. This is where AI and ML are truly making a tangible difference in how your phone communicates with the network. Now, what exactly is CSI? Well, it stands for Channel State Information, and it's basically all the amazing details about how your wireless signal travels between a 5G tower, which we call a G node B, and your phone, or UE. Think of it like this. Imagine you're trying to talk to someone across a room. You need to know if there are obstacles, how loud you need to speak, or if the acoustics are good. CSI is that exact kind of information, but for the complex and dynamic world of 5G. Your phone actually measures these signals, figures out the precise CSI, and then sends a CSI report back to the G node B. This little report is absolutely crucial because it empowers the G node B to optimize how your data gets to you, ensuring it's delivered super efficiently. It's like your phone giving the tower a real-time heads-up on the absolute best way to send you information. This is where AI and machine learning step in. 3GPP has been investigating some truly innovative ways to make CSI even better using these advanced technologies. They focused on two main areas: making those CSI reports smaller and faster to send, and intelligently predicting how the signal will behave in the future. Let's talk about CSI compression first. Imagine you have a huge digital file you want to send quickly. What do? You compress it, right? It's the same idea here. With AI/ML-based CSI compression, your phone uses an AI model, like a super smart little helper, to efficiently encode the CSI information into a much smaller package. Then, the G node B has its own complementary AI model that decodes it. This is what we call a two-sided AI and ML model, because both your phone and the tower are working collaboratively, each contributing to the process. This two-sided AI model can actually compress the raw channel data your phone observes, or it can even compress something called a precoding matrix. Now, compressing that precoding matrix is particularly neat because it integrates very well with how current 5G systems already handle CSI feedback. That's why it's been a significant focus in the recent 3GPP discussions. So how do we actually implement this AI magic for CSI compression? Well, one of the most powerful and popular AI architectures for this kind of task is called a transformer model. You might have heard of transformers in the world of large language models, but they're incredibly versatile and perfectly suited for handling complex sequential and spatial data like channel information. On your screen, you can see a simplified block diagram of what a transformer model looks like when it's configured for CSI compression and reconstruction. Think of it as a super smart encoder and decoder working in tandem. The encoder takes in the original, often high-dimensional CSI data, processes it, and generates a compact, low-dimensional representation. Then, the decoder at the other end takes that compact data and strives to perfectly reconstruct the original CSI, ensuring minimal loss of critical information. Here at WirelessPro, we've implemented this very architecture in our simulation software. We've taken these advanced AI concepts and translated them into real-world code, like the snippet you see here. This allows us to rigorously test and optimize how these AI models perform in actual wireless network scenarios, helping us push the boundaries of what's possible in 5G advanced and beyond. It's all about turning cutting-edge research into practical solutions for better, more efficient wireless communication. Getting these two-sided AI models to work effectively over the air in a complex and dynamic 5G network comes with considerable hurdles. Chief among these is the immense challenge of training these models. Imagine trying to teach two different AI systems to work perfectly together. It's incredibly tricky to synchronize them. 3GPP has been exploring various ways to train them, with varying levels of collaboration and information exchange between the network and your phone. And it gets even more complicated when you consider the diverse ecosystem of phone manufacturers. Your phone might be from one company and the G node B from another. We need to ensure their CSI decoders and encoders are fully compatible and interoperable. If you have a common CSI decoder at the G node B, it needs to be able to accurately understand the reports from all sorts of different phones, regardless of their make or model. And if a new phone with a new AI architecture comes out, it could potentially mean retraining a whole bunch of systems across the network. It's a significant puzzle, but 3GPP and the industry are actively working on robust solutions to make this process smoother and more scalable, especially through exploring different training approaches and standardization efforts. Okay, let's switch gears a bit and discuss another critical problem that CSI Feedback faces: channel aging. Think about this. Your phone sends a CSI report at a specific moment, but by the time the G node B actually processes that report and uses it to transmit data to you, the wireless channel might have subtly changed. It's like getting a weather report from an hour ago. It might not be perfectly accurate anymore for the current conditions. This aging of the CSI becomes a much bigger deal when you're moving fast. If you're zooming down the highway, the wireless channel changes very quickly due to fading and interference, making that reported CSI outdated even faster. This is a particular headache for something called MU-MIMO, or multi-user multiple input, multiple output, which is super important for simultaneously getting lots of data to many users at once in massive 5G advanced deployments. If the CSI isn't fresh and accurate, MU-MIMO performance can really suffer, especially at medium to high speeds, leading to reduced throughput and efficiency. So how do we tackle this challenge of outdated CSI, especially with faster-moving devices? This is where time-domain CSI prediction comes in. And the cool part is, unlike CSI compression, which typically needs both your phone and the tower working together, CSI prediction can often utilize a one-sided model. This is a big win, because it means you don't necessarily need that complex, two-sided synchronized training across different vendors. One vendor can train the prediction model, and then either the G node B or your phone can independently do the predicting, simplifying deployment and management. To achieve this, we can employ powerful neural network architectures. Take a look at the screen. Here we have a block diagram of a CNN-LSTM model, which is fantastic for this kind of time series prediction. This model cleverly combines the strengths of convolutional neural networks, which are great for extracting spatial features from the CSI data, with long short-term memory networks. LSTMs are particularly clever because they're specifically designed to understand patterns in sequences of data, allowing them to remember important information over both short and long periods. This makes them incredibly useful for predicting how the wireless channel will evolve over time, helping us anticipate changes and keep the CSI effectively fresh even when the physical channel is dynamic. So there you have it. CSI is absolutely vital for efficient 5G and future 6G networks, and artificial intelligence and machine learning are truly paving the way for some exciting enhancements. From making CSI reports cleaner and more efficient to intelligently predicting future channel conditions, it's all about making your 5G experience even faster, more reliable, and ultimately more enjoyable. What are your thoughts on how AI is shaping the future of wireless communication? I'd love to hear them. Let me know in the comments below. And don't forget to install and try WirelessPro for more tech deep dives and insights into the world of advanced wireless.